Hey, welcome everyone to lecture 8 for the Vesper Data Science course. Today we'll have the great pleasure to have a guest lecture, or I should say a lecture, by one of our teaching mentees. Juja will be teaching the lecture on maps in D3. And for those of you who are PhD students, you're probably aware that like as a PhD student, you're taking these like teaching menteeships. This is a course and this is a little bit different from a TA. So we want teaching mentees to actually also get hands-on experience. And so typically TMs do teach 1 or 2 classes every semester. And today it's Shuja's turn. So I'll just turn it over. I'll be here to moderate any questions that you might have.
Hi, everyone. Today we are going to introduce how to draw maps with D3. Before I start to talk about how to draw maps, I have to say maps are heavily overused. So a lot of information that is printed on top of maps would be better shown in other type of chart. For example, if we are going to compare data of 5 largest cities in the US, we don't need to do that on a map because everyone knows where the 5 cities are. And if we plot this on a map, we will give up our most important visual channel, the positions, which means we are no longer free to place things where we want. However, there are still a lot of cases when the spatial position is paramount, and in those cases, you should definitely use a map. So let's get to how we can visualize data on top of maps with D3. Generally, there are 2 approaches. The first approach is data maps. A data map is usually an abstract map, and we can easily build data maps using D3. They are mostly used when you want to communicate trends and let users compare between different areas. In those maps, you have full control over how the map is colored and how the encode information on top of the map. Typically, you cannot zoom in to show more details. This does mean that you cannot zoom the map at all. Of course, you can use the scale function with some interactivities to make part of the map larger or smaller, but it means that it usually does not bring more detailed information about the data. So thinking about when you use Google Map, when you zoom in, what you see will change. You will see more details about the streets, about the buildings and the restaurants. But when you zoom in a data map, the information you see generally does not change. So the next approach is street maps. This kind of map is usually used when you want to show something in the context of a real street map, like a Google map. And it is best built using APIs such as Google Map API and the OpenStreetMap API. Here is an example of how it's used with D3. So in this example, the Google Map API is called, and then they use the D3 to draw some circles to reflect the positions on top of the map. Street maps can be zoomed in and zoomed out. When you zoom in, what you see will change, and you will get more information, more detailed information of the street and the buildings. So this is great when you really care about the positions of items. In this lecture, we will be talking about both street maps and data maps, and I will give you examples of how to use both of them. So first, let's talk about data maps. This kind of map can be used can be created by using purely D3. These maps are usually made with the intent of showing the distribution of data that has a meaningful geographic component. Here are some examples of how people use data maps to tell stories. So this map visualization shows the median distance of people in the US are from their mothers. And you can see from this map, you can see people really live close to their parents, as the largest median distance is only 44 miles and the overall is 80 miles. And another example I'd like to show is this hurricane visualization. It shows the impact of a hurricane over time. As you can see here, it is actually a quite cool visualization with some animations for people to track the wind and to know how the positions of the wind change according to the time. As you can see in all these data maps, the map itself is more like a sketch, and they mainly focus on the specific data and the trends of the data. Before I introduce how we can render the map itself using D3, let's first take a look at the format of the geographic data that we used on the web. So this part is very important for you to understand because you will also use them in your next homework. I will introduce two different formats, the Geojson and the Topologists. They're not hard to understand, and the way they represent the data is actually quite straightforward. The first format is called Geojson. This describes the geography as a combination of longitude and latitude coordinates. There are different types of Geojson objects. For each object, it has an entry describing the type of this object and another entry to specify the coordinate information about this object. The object can be as simple as a point, and it can also be as complex as multi-polygon or some feature collections. But essentially, they are just described as the points in the space. So for a simple point object, the coordinates are just the longitude and latitude values of this point. And a multi-point object is a list of positions where each position is corresponding to a single point. We also have this line string object. So for a line string object, the coordinates is a list of positions that forms a continuous line. And for the multi-line string, it's just a list of line strings with So the coordinates here is a list of lists. Within the list, each item is representing a single line. That is what we have for the line string here. And polygons and multi-polygons are very similar to the line strings and multi-line strings, except that they are capturing polygons. And a geometry collection contains an array of different types of geometry objects we introduced before. You can also have a feature object which contains one of the above geometry objects with some properties attached to the geometry object. For example, in this feature object, there is a property name attached to this polygon object. The property does not have to be named. It can also be some other things like colors or any other information that in your visualization you would like to display on top of the geometry object. And a feature collection is just a list of feature objects. It allows the features to have different types of geometry objects and to have different properties attached to each geometry object. And Topologists has very similar data structure format to Geojson, but a bit more complicated. It is derived from Geojson, but rather than representing the geometries directly, geometries in Topologists files are stitched together from shared line segments called arcs. For example, if you are going to draw two adjacent states of the US map, and if the data is saved in a Geojson file, the two states will be stored in two different geometry objects, and therefore their shared border will be saved twice. So the main idea of how Topologists stores the geometric information is to try to stop this kind of duplicating and to eliminate the redundance to offer more compact representations of the geometry than Geojson. So this is an example of what a Topologists file looks like. The type here indicates it is a Topologists file, and it has transformation information, and objects contains different types of geometry objects. So in general, it is quite flexible to store any kind of geometric information in a Topologists file. However, D3 only handles data in Geojson format. So you have to use a library to convert Topologists to Geojson. In your next homework, we will provide you a Topologists file. So you will need to do this kind of converting to get the Geojson format and render the map with D3. This is how you include the map library in your HTML file. And the usage of this library is actually quite easy. So you only need to put this one line of code. It takes two parameters. The first input parameter will be the whole Topologists file, and the second input is the object that you are going to convert. So here, we use this library to convert the Topologists file we show here, and we first put the whole JSON file to the first parameter, and then we specify the object we would like to convert is the US states. It will return a Geojson format. And since the US states is a collection of geometry objects, so the returned JSON file will be a feature collection object. And as you can see, it is logged here. This GeoJSON object contains a list of 253 features. So after converting Topologists to Geojson, remember when you actually draw the objects using D3, you need to bind the Geojson.feature array as the data to the D3 selections. Because the returned Geojson is an object, and when we bind data, we actually want an array instead of an object. I will explain more about how you actually use this array in the following examples. So after we have this GeoJSON object, let's take a look at how we use projections to actually render these coordinates to a SVG element. Let's take a look at this example here. You can see the coordinates are within this geometry object, and there is a property called name that indicates this shape representing Alabama. So remember, we talked about these coordinates are actually latitude and longitude values, which are spherical coordinates. And in this part, I will introduce how do we project the lat and long values onto a 2D surface so that we can use to draw in an SVG element. There are many different ways to do projections with various advantages and disadvantages. We will discuss them later in the class. Let's first take a look at an example of how to use projections to transform the coordinates. Here is a very simple example of how we do it. The data we use here is only a single point. And the first step is we select the SVG and we have the width and height of this SVG element. So in order to convert the lat and long coordinates to fit the 2D coordinate system of our screen, we need to create a projection function. So here we choose a projection function to use in this example. And then we do a translate to center the map in our SVG element. The next step is we input the original positions of this point to this projection function, and it will give you the output, the converted positions that you can use to plot. Let's see what we get from this simple example. So here, the single point is plotted on this SVG element. If you take a look at the elements, you will see here is our SVG element, and inside it, there is a single point, and the console prints the original position and the projected position for it. So this is a very simple example to give you an overview of how projection functions works. Here are a lot of other projections in D3, and here is a short view of a list of projections that's supported by D3. As you can see here, it provides you an animation to display different kinds of projection that is supported by D3. And you can see the list is quite long, so there are a lot of different projection functions you can choose to use. And here is another observable comparing example. So for the comparison of two projection functions. So here you can choose any two of the projection, and it will show you how they are different from each other. And there are actually some quite fun projections. Like I remember this one will project the everything within a star area, and there are a lot of others you can explore yourself. So once the coordinates are projected to screen coordinates, let's see how do we convert the polygons into an SVG path. In D3, there is a GeoPath function to help us to do that. This is a path generator that takes in any Geojson feature or geometry object, and it will return you a formatted SVG path. I will show you how to use this function to render a US states map. Like the previous example, here we have this SVG element, and here we choose a projection function, and we do some translate and scales to specify where and what size of the map we want to be on our screen. Then we call this D3 the GeoPython to define a path function. Remember, the path here is not does not refer to an SVG element. It is a function. It will take the original points positions and returns the projected points that we're going to use to draw the path. Here we load the Geojson files, which contains the geometric information we will use to draw the map. And I think we can actually take a look at what this file looks like. Yeah, so if you take a look at the console, you will see this JSON file contains a feature collection with a list of 52 features, and within each feature, it refers to a state. It contains the geometric information of this particular state and the ID and the property name attached to this state. The next step is to bind the data to what we have selected here. So remember, I've mentioned earlier, it is very important for you to not bind the entire D3 object. You only need to bind this features array as data to your D3 selection. So in this way, we create a path for each state. And here we use the D attribute to define the path. So within the attribute, you call the path function here, and it will returns you the path of each state. And now after that, if we call the function, it will render the map for you. Let's see this in a new page. So this is the map we rendered, use the previous code. And if we take a look at the elements inside it, we can see here is the SVG element. And within this SVG element, since we choose to render the map on the map layer, the path element will be put in this map layer. There is like just a bunch of paths that each path represent the borders of a state. And you can also use this graticular function to draw the actual latitude and longitude lines within this map. You can see here, this is the actual latitude and longitude lines within this part of the map. So after we have this base map, we can do something interesting on top of it. Here, I will show you how you could add some markers or assign colors on top of the map. Let's first take a look at how do we add markers on top of a map. Here we are going to draw the size of the 50 largest cities in the US. And the data file here contains several columns with the rank and the city's name and the population, the latitude and longitude coordinates of each city. The first step is to create a base map, which is just the same as what we did before. You choose a projection and you create a path function, and then you draw the path to the map layer. Then the next step is to load the data, is to load this CSV data we are going to use to draw the circles. So actually, after you have the base map, the following step is actually quite similar to how you draw a single scatter plot. The first thing is you select a layer that you would like to draw the circles, and then you bind the data to it. The data will be an array of with each element to be a city. And then you specify the attribute, the x, y coordinates, and the radius of each circle. The only thing you need to be careful here is when you assign the x and y coordinates, you will still need to use this projection function to convert its coordinates into a projected position. And this is to just make sure your circles are on the right positions on top of the map. And also, we define the radius to be corresponding to the populations of each city. And then you can do some styling of the circles as what you did for a scatter plot. And here is how it looks like. Let's take a look at the elements inside this map. So if you look at the details of this map, you will see there are still two layers. The first layer contains the path that corresponds to each state's border. And the second layer contains all the circles that represent the city, with the size of each circle representing the population of this city. And you can see by using the projection function, the positions of the cities are put exactly where they are on the actual map. Here is another example to assign different colors to different states according to some properties of the state. Here we're going to color the map by its agricultural output. And the SVG files we are going to use here contains two columns. The first column specifies the state name, and the second column specifies the agricultural output values corresponding to each state. The trick here is we need to join the data about the agricultural information to the geographic information data. So the first steps are the same. You select the SVG, you define the projection and the path function. Then we need to define a color function that takes a numerical value and returns a color that represents that value. Because remember here, all the values we have is numerical. So we need to use quantize the scale that to sort the data values into buckets of colors and returns a specific color when you input some numerical values to this function. We define the range to be the colors we want, and then we load this Geojson file for drawing the map, and we load this CSV file for us to color the map. After we have loaded this CSV file, we can define the domain of this color function. Here we would like to, here we set the domain of the color function to be the minimum, to be between the minimum value and the maximum value of this agricultural output. So within this function, you just input this state data, and you specify the minimum value to be the column value, which is referring to the agricultural output. And after that, you need to convert the data array to an object. This is for you to easily look up the values for each state. So you create a new object called data lookup, and for each element inside the state data array, you assign the you make the state name to be the key and the values to be the values in this object. So remember D3, the cells, CSV will read the values as strings. So you need to use this parse float to convert them to floats. Now the next step is to join these output values to your geometry information. So for the features inside the geo file, for each feature, we create a new property called values that will equals to the agricultural output of this state. And after we have assigned the values to the properties of each feature, we can then find the data and create the path for the geo features. The first steps are quite similar to what you did before. And the one more thing you need to do is you fill each path with this color function. And inside the color function, you use the property value as the input, and it will color the map according to the agriculture output values for each state. So if you take a look at this Svg element, inside this element, there is one layer called map, and you still have this path element for each state, but you have like one more thing that specify the color, which is different for each state. This is what we get from the color function we defined. So now we are going to talk about street maps. Street maps is not as commonly used as data maps in data visualization because you have to use an API to draw them, and that means you might lose some control of the map properties. But it is still quite useful when you think the spatial context of your data is very important because for street maps, you can always zoom in to get more details. And here are a few examples of street maps. For this map, I think it shows the, I think it's the population of famous people within US. So in this overview level, you can see the distribution of this population for state and maybe large cities. And you can always zoom in to a particular area to see more details of this distribution and to see how it looks like within smaller cities or counties. Another example is about the is about the white corner, crime distributions. So you can always zoom in and zoom out to see the crime risk within a specific area. And it will tells you how high the risk within the area you are looking at. Finally, there is a street map visualization that tells you the pizza restaurants within New York City. And you can always zoom in the map to see where the restaurant's location is. So the street map is very useful when you would like to show the exact positions of something you are visualizing. And the most common used street map API is this Google Maps API. And to use Google Map API, the most important steps is, there are 4 most important steps to use that. The first step is that you need to get an API key to use with Google Map. So if you go to this webpage, Google describes.
Quick interjection. Can you increase the font size if possible?
Oh, yeah.
A little more. And thank you.
Does this looks bigger?
Yeah, great. Thank you.
Okay, so if you go to this website, you will see a detailed description from Google to teach you how you can actually request an API key from Google. After you have the API key, you need to load this Google Map API using the script tag. So let's see a simple example of how we do this. After we request the API key from Google Map, we will need to use a script tag here to put the API key we got, and for you to use it to draw the Google Map within the HTML file. And the third step is you need to create a div element with an ID that will be held on the map. So here within the body element, we create a new div element with ID equals map. And the last step is call this Google's the map function inside your JavaScript code to create a map inside this newly created div element. So within our JavaScript code here, we first need to specify which div element we would like to use to put our map. So here we use this element we just created. And then we can specify some options that we would like to use to customize our Google Map. So here we specify the center to be this location, and we specify the zoom level. The zoom level refers to like how much details you would like the users to see when they first load the web page. After you have these options, you are now going to call this Google the map function, and the first input parameter is the map container, that is the div element we select before, and the second input is going to be your options that you use to customize your map. And here is how your Google Maps in the web page will be looks like. It is actually still a Google Map, just with the center you choose and with the zoom level you specified. So let's talk more about the map object. The map object you use is to define a single map on the page. If you want to, you must create a new object for each new instance of a map that you want on the page. So there are two main parameters for this map object. The first one is where you would like to put this map, like to specify the div element. And the second one is the options you would like to customize your map. So for the options, there are a lot of parameters that you can use to styling your map, but there are only two required parameters. The first one is the center, and then it is the zoom level. For a zoom level, it will be helpful for you to know like how the numeric zoom level is corresponding to the amount of details your users can see in the map. So for zoom level 1, it will give you the most overview of the map. So it is the word level, and for level 5, it gives you the details of landmass and continent. For 10, it is for city, and 15 for street. And for level 20, it gives you the most detailed information of your map. It will including the buildings within the map. Besides that, you could have much more parameters that you use to style your map. Here we assign another parameter called map type ID. So the map type you can use from the Google API there are 4 types. The first type is roadmap. It is the default one. So it just looks like this. And another is the satellite. It will display the satellite images of the Google Earth. And you can use a hybrid one, which displays a mixture of normal and satellite views. And you can also use terrain, which display a physical map based on the terrain information. There is another way to set a map type programmably. This is after you have defined the map object, you can attach this map ID to it. And you can do some more complicated styling of your map. Here is a description of how you actually do it. So Google provides you a detailed documentation of what kind of styling you could do and how you do it within their website. And you can see there's a lot you could do to make your map looks much more different from the original Google map. Here is an example of what we created. And once you have the Google Map set up, you might want to add some D3 elements to highlight some geographic information on top of the Google Map. So this is where overlays comes in. Overlays are objects on the map that are tied to the latitude and longitude coordinates. So when you move, when you drag or zoom the map, they will move according to your movement. The Google Maps API provides an overlay view class for you to create in your custom overlays. And it provides you some functions for you to create these three visualizations on top of the Google Map. Here I will go through an example to introduce how you actually use this overlay class to create these three visualization on top of the Google Map. The final result will be looks like this. So you will be able to add circles to the on top of the Google Map. The first step is you need to create a new overlay class. Oh, let me first introduce the data we used here. So for this example, we will look at the recorded UFO sightings from 1965 to 2013. And as you can see from this CSV, it contains the time and the locations and the durations of each report. So we will plot each of these reports on the map, and with the size of the circle equals to the durations. To do this, the first step, you still need to draw the base map. As I introduced before, you set options and you create a map object. And then after you have the map object, we can load the data, and we choose what data we would like to use to for our visualization. For here, we only want the data from the US, and we select the top 200 samples from this report. After you have all this prepared, the next step is you need to create a new overlay class. And then you implement an onAdd function for your overlay class. This function is for you to add a container when the overlay is added to the map. And within this onAdd function, you actually specify which layer you would like to draw these circles. And the next step is you using this overlay the draw function. Within this overlay the draw function, it will handle the video display of your object. It will be called when the object is first displayed on your web page. And within this draw function, what we did is quite similar to what we did for drawing circles before. You still need to use this get projection to get a projection function, and you need to define a circle scale, which will provide you a radius scale from the duration values. And then you select the SVG, you append circles and set attributes of the circles to draw them on the SVG element. Then you might want to do some proper transformations to put them in the right positions. The last step is after you have all these functions prepared, you need to bind the overlay class to the map. So use overlay the set map to tell the system that you would like to bind this overlay to the map you decided previously. And this will be the result. Let's see it in a new page. So in this way, you put the UFO sighting data as circles on top of a Google map, and you can always zoom in and zoom out to see the detailed distribution within each particular areas. So that's how we did this visualization using street maps. And I think that's everything I'm going to share today. Do you have any questions?
Are the office hours right after this, or are they at?
My office hours will start at 2.
Okay, thanks.
Okay, I'll turn off the recording. Thank you, Shuju.